So imagine, you're just walking down the street and you trip and hit the ground.
Ouch.
Right. And the physical reality of that impact, I mean, the pain, the sudden halt, the weight of your own body, it all feels completely absolute.
Oh, absolutely. It's
Yeah.
undeniable in that moment.
But what if the gravity pulling you down isn't actually a fundamental force of the universe at all? What if it's just a byproduct of the universe processing data?
That is, well, it's a massive question.
Yeah.
And it really challenges everything we think we know.
Exactly. And that is our mission for today's deep dive. We are exploring this wildly fascinating theoretical framework called Celominisignum.
Right.
And we're relying on a stack of 3 very specific sources for this. We've got a dense 2-page conceptual brief, a comparative analysis, and this really interesting draft email.
Yeah, all of these were written by Howard DeLaCruz-Bancroft.
Right. He's a former tech contractor at Los Alamos National Laboratories, a supercomputing challenge coach, and currently an AI researcher. So, he's got the chops.
He really does. And the stakes of his framework are, frankly, they're substantial.
How so? Like, for the listener, what does this actually change?
Well, applying a computational lens to theoretical physics, it actively challenges our baseline assumptions of reality. I mean, for nearly a century, the standard model has treated particles and forces as the immutable foundation of everything.
The building blocks, basically.
Exactly.
Yeah.
But we are analyzing a hypothesis here that suggests the physical stuff of the universe is secondary.
Wow.
Yeah, it argues that the primary reality is actually the data dictating the identity of that stuff.
Okay, let's unpack this, because Howard's framework doesn't just exist in a vacuum, right? The comparative analysis positions Celominisignum as a direct response to Dr. Erik Verlinde's work.
Right, specifically his paper on the origin of gravity and the laws of Newton.
Yeah. And Verlinde basically made huge waves in the physics community by arguing that gravity is strictly emergent. He strips it of its fundamental status entirely.
He does. He derives gravity entirely from information, entropy, the holographic principle, and this concept called coarse graining.
Okay, so wait, I need to wrap my head around that. Walk us through Verlinde's mechanics here.
Sure. So it relies heavily on the thermodynamic properties of black holes. This builds on the work of people like Jacob Bekenstein and Stephen Hawking.
Okay, the heady hitters.
Right. So there's this thing called the holographic principle. It posits that all the information contained within a 3D volume of space can be mathematically described by the 2D boundary around it.
So like a hologram, the 2D surface holds all the 3D data.
Exactly. Now, if you introduce a mass into that volume, if you move a mass around inside it, the information encoded on that outer boundary has to change to reflect the new state.
Okay, that makes sense. And this is where coarse graining comes in, right?
Yes. Coarse graining is the critical mechanism here.
Because when we look at the universe at our massive macroscopic level, we're essentially looking at a blurred image. Like, we lose all the microscopic details, the tiny quantum fluctuations.
Exactly. We can't see the infinite microstates. But mathematically speaking, the universe still has to account for that lost information.
So Verlinde is arguing that this underlying quantum information has a statistical tendency to just redistribute itself, to maximize entropy.
Right. And that statistical drive generates what he calls an entropic force.
So we don't actually see the data shuffling around behind the scenes. We just feel the macro-level mathematical compensation for it.
Which physically manifests as gravity.
That is just wild. So it's kind of like temperature, right? Like, temperature isn't a fundamental particle. It's just the macroscopic result of billions of atoms jiggling around.
That's a perfect analogy. Verlinde is proposing that space itself is the storage medium, like a hard drive. As matter shifts, the entropy of the encoded information shifts.
And his math is solid on this.
It is. The derivations in his paper are rigorous enough to actually yield Newton's laws of motion and Einstein's equations of general relativity straight from these entropic gradients.
So gravity is just an illusion of statistics. But, okay, here's my pushback on this, because there's a huge philosophical tension here if we're looking at a strictly entropy-first model.
Oh, absolutely. What's fascinating here is how the second law of thermodynamics plays into it.
Right. The second law dictates that entropy strictly increases over time. The universe mathematically tends toward disorder, right? It dissipates energy, randomizes things.
It's the universe getting messier, statistically speaking.
Exactly. Yet the physical laws governing our reality are incredibly consistent. I mean, planetary orbits, molecular bonding, gravity, they all operate with this relentless precision.
They do. They're highly structured.
So if Verlinde says gravity emerges from these entropy gradients, how do you derive highly structured, persistent physical phenomena entirely from a drive toward randomization?
Right, you're basically asking pure chaos to mathematically guarantee persistent order. It's super counterintuitive.
It really is. It feels like a paradox.
And that precise tension is the launch pad for Celominisignum. Because in Verlinde's pipeline, the causal chain goes from information to entropy gradients and then directly to emergent gravity.
Right.
But that leaves a massive gap regarding where the initial resilient structural rules even come from.
And that's exactly what Howard DeLaCruz-Bancroft is addressing. He proposes this architecture where order, rather than entropy, is the absolute baseline of the cosmos.
He completely flips the starting assumption. But, and this is crucial, he doesn't discard Verlinde's entropic gravity, and he doesn't reject thermodynamic laws.
Right, he just says observable randomness and entropy aren't the fundamental starting points. They are secondary. They're downstream effects.
Yes, he calls it a result of incomplete coherence.
Incomplete coherence.
Yeah.
So by positing an order-first universe, he bypasses that paradox of building perfect physical laws out of pure statistical noise.
Exactly. But starting with ordered information as the base layer means you need a new architecture to map the translation from data to physical reality.
And this is where we get to the vocabulary of the brief, which is fascinating. Howard introduces the IEMA.
Right, the Informational Ether Matrix Array.
Which sounds like sci-fi, but the brief is very careful to specify that the IEMA does not directly represent mass or energy or even spatial dimensions.
No, it doesn't. It functions purely as an informational placeholder layer. Its sole purpose is to preserve relational identity and map possible states.
Okay, here's where it gets really interesting, and to help wrap my head around this, I thought of like computer science, like how a computer's operating system allocates memory.
Oh, that's a great way to look at it.
Right, because before a video game ever runs, before any graphics are rendered on your screen, the OS assigns memory blocks and establishes pointers.
And the memory address itself has no mass, no pixel color, no audio.
Exactly. It strictly defines the identity and the boundaries of the data. It ensures that a block of data meant for your game character maintains its integrity separate from the rest of the system.
And the physical rendering we ultimately see on the monitor, the gravity in the game, the light, all of that is downstream from that underlying identity preservation.
Yes. So the mathematics of that memory allocation analogy map perfectly onto the two coherence metrics Howard introduces, the IAC and the IOC.
Let's break those down. The IAC, or Information Alignment Coefficiency, act as a structural integrity metric for our theoretical memory pointer.
So it measures the alignment right in the moment.
Yes, the instantaneous alignment, how internally coherent a specific identity is at a single frozen microsecond in time.
Okay, and then the IOC, the Information Order Coefficiency, brings in the time domain.
Right. It measures the persistence of that identity over time.
So it basically quantifies how well that informational structure survives across successive states.
Exactly. If the IAC is the structural integrity right now, the IOC is the mathematical guarantee that the data hasn't been corrupted over the last hour.
Okay, so what happens when a system experiences huge shifts in these coherence levels? Because the brief mentions these processes called coupling and decoupling.
Yeah, and these aren't just abstract math problems. A severe drop in the IOC, which is a failure of identity persistence, that actually bubbles up through the layers to alter the observable system.
So it changes what we physically see or feel.
Yes, it would manifest as a physical phase transition or a degradation of energy or even an entropic release.
So comparing Verlinde to Celominisignum, Howard's pipeline starts with ordered information in the IEMA. That matrix establishes coherency and identity, right?
Right, governed by the IAC and IOC metrics.
And then, only after identity is established do you get the entropy response, the universe reacting to incomplete coherence, and finally that dictates the matter, light, and gravity we see.
He basically argues that the second law of thermodynamics is just the universe's garbage collection routine.
I love that.
Just cleaning up decoupled, corrupted informational structures.
It's a beautiful theory, but, a beautiful theory is just philosophy unless you can actually test it.
Absolutely. Theoretical physics demands empirical verification. If you introduce an unobservable matrix like the IEMA, you risk being dismissed as pure philosophy.
But the sources make it clear that Howard is explicitly pushing for falsifiability. He doesn't just want to philosophize, he outlines exact conditions under which Celominisignum should be rejected.
Which is the mark of good science. He states the theory should be discarded if assuming an order-first architecture doesn't actually improve computational simulations.
Or if the coherence metrics don't offer any predictive value over the standard entropy-only models.
Right. He is heavily leveraging his Los Alamos background to anchor this in testable methods.
And he proposes 3 highly specific, really rigorous directions to search for the signature of this order-first universe. Let's walk through them. The first one is coherence threshold behavior.
Yes, and he wants to test this via Kuramoto Oscillator synchronization simulations.
Okay, Kuramoto oscillators, what exactly is that?
So the Kuramoto model is a mathematical framework. It's used to study how massive populations of coupled oscillators behave, specifically predicting how chaotic systems spontaneously synchronize.
Like fireflies flashing together in a forest.
Exactly like that. Or pacemakers in the heart. So Howard hypothesizes that if you introduce severe perturbations, major disruptions into a simulated network,
The networks governed by a stronger underlying informational order will maintain their phase synchronization longer than systems governed just by local thermodynamic energy.
right, he is looking for a mathematical signature where stability is predicted more accurately by his IAC and IOC metrics than by traditional physics limits.
That's brilliant. Okay, the second prediction leans on his AI background, emergent efficiency.
This one is fascinating. He asserts that order-first training methods in machine learning will need way less computational overhead than entropy-maximizing methods.
So he wants to test this in controlled reinforcement learning environments.
Right. In a standard Markov decision process, an AI agent explores a massive state space trying to maximize a reward.
Trial and error, basically.
Yes. But if the environment's architecture assumes an IEMA-like structural coherence, meaning it limits the exploration of states that violate fundamental identity, the agent should learn the optimal policy much faster.
Using drastically fewer compute cycles. So he's testing a fundamental physics hypothesis by measuring the efficiency of an artificial neural network.
It's a very clever interdisciplinary approach.
It really is. And the third methodology is stability mapping. He hypothesizes that observable physical phase transitions will correlate more tightly to his coherence metrics than to raw thermodynamic energy.
Right. He suggests modeling perturbations in graphene or other complex lattice structures.
Because graphene's hexagonal lattice has highly predictable failure points when you stress it, right? Usually measured in electron volts.
Exactly. Howard suggests that an informational breaking point, like a localized collapse in the IOC metric, must mathematically precede the physical thermodynamic breaking point.
Meaning the data breaks before the physical material breaks.
That's the hypothesis. And the ambition of these 3 tests really reflects the staggering scope of Celominisignum.
Oh, absolutely. I mean, Verlinde was narrowly focused on deriving Newtonian mechanics and general relativity. Howard is swinging for the fences here.
He really is. By positioning identity and coherence as the immutable base layer, the implications scale aggressively upward.
Yeah, the comparative analysis notes that if coherence is the bedrock of physics, this framework extends way beyond standard quantum mechanics.
It provides a potential mathematical bridge to the emergence of consciousness, for one.
Right, assuming the human mind is basically just a highly complex, self-sustaining informational identity.
It touches on the limits of AI simulation and even probes the fundamental nature of moral order, suggesting that structure and identity preservation aren't just human concepts.
They're literally the laws of nature. Which brings us to the human element of all this, because you have an AI researcher trying to get this massive idea heard by the establishment.
Right. The draft email to Dr. Verlinde, it's a literal manifestation of this convergence.
The tone of this email is just fascinating. It's a great look into the sociology of modern science. Howard is incredibly humble.
He is. He introduces his background at LANL, mentions his supercomputing challenge work, and links to his YouTube channel at Celominisignum.
And he praises Verlinde's paper naturally, but then he makes this remarkably modest request. He literally says, I am not asking for endorsement.
Which is such a smart move. He just asks Verlinde a very collegial question.
He asks if there's conceptual room within emergent gravity for informational order or coherence measures to serve as complementary explanatory variables alongside entropy.
He's not trying to tear down Verlinde's work. He's just asking for a seat at the table.
Right, and he actively asks for his own falsification. He asks Verlinde to recommend any papers that might challenge or completely shatter his framework.
And if we connect this to the bigger picture, Boundary crossing and exactly. But Howard's approach-seeking dialogue, offering an independent variable to complement entropy, inviting critique, it's a masterclass in navigating that friction.
It's the best of the scientific process. So what does this all mean for you, the listener? Because most of us aren't doing math on holographic spacetime in our living rooms.
No, probably not. But the core idea here shifts how we contextualize our entire existence.
Right. We look around and the universe always seems to be degrading into chaos, just driven by entropy. Things break down.
But this framework argues that the absolute base layer of reality is actually prioritizing structure.
Prioritizing identity and coherence. It's a profound paradigm shift. It means order isn't just a temporary accident in a decaying universe, it's the prerequisite for existence.
And that leaves us with a really provocative final thought.
Lay it on us.
If Celominisignum holds true, and the physical universe emerges from an underlying matrix whose primary job is to preserve identity and coherence, does that mean the cosmos is fundamentally wired to remember who and what things are? Right. If identity preservation is the bedrock law of physics, dictating everything from a galaxy's gravity to the stability of an atom, perhaps our own human obsession with finding and preserving our individual identities isn't just a psychological quirk.
So you're saying our need to know who we are might actually be a direct reflection of the deepest laws governing the universe itself.
Exactly. It might just be the universe doing what it fundamentally does best.